Our next keynote will be from Yulia Uvarova, Senior Principal Research Scientist and Director of Autonomous Sensors Future Science Platform at CSIRO Mineral Resources. Thanks, Yulia.
Good morning, everyone, and thank you very much for this opportunity to speak on behalf of CSIRO. And thank you, Marianne, for the nice welcome to country. That was beautiful. So Commonwealth Scientific and Industrial Research Organization, or CSIRO, is Australia's national science agency. It is one of the world's largest multidisciplinary science and technology organizations. Currently, we have more than 6,000 staff working across 48 sites in Australia and globally, and we host 4 sites just here in Perth. We also host state-of-the-art national research infrastructure, and our main focus is to deliver impact to Australia, not only economic, but societal and environmental as well. So CSIRO is focused on solving the greatest challenges through innovative science and technology, and we're currently working on these 6 challenges listed in this slide. And you can see that sustainable energy and resources challenge is one of them. Nearly a decade's research has shown no single technology will achieve the transition to net zero. Rather, we will need a coalition of low-emission technologies, and Australian minerals, they are and will continue to be central to this. The transition will require new infrastructure to generate, store, and transmit energy, like new transmission lines, solar fields, wind farms, and energy storage capacity. It will also require exploration and responsible extraction of critical minerals, the building blocks of these downstream technologies that will underpin decarbonization. And I'm here today to talk to you on behalf of one of the business units that we host at CSIRO, the Mineral Resources Business Unit. In CSIRO, we have actually 11 science business units, everything from agriculture and food to health and biosecurity to manufacturing, and mineral resources is one of them. We have about 350 dedicated staff, scientists and engineers, with a wide range of expertise and skills that I listed, some of them in this slide. And these researchers and engineers are hosted within 5 research programs. And I gave you the names of the directors, so if you have any questions, you can contact them directly. And you can see that our research spans across the whole minerals value chain, so everything from exploration to mining to ore sorting and to mineral processing. And you may notice that little logo with Horizon 1 on the slide. So what do I mean by this? At CSIRO, we adopted McKinsey's model, which is called 3 Horizons of Growth, to science and research and development. And in this model, Horizon 1 is all about modernizing core activities, solving the challenges of today. Horizon 1 or 2 is looking at something new and perhaps solving problems or trying to solve problems in 5 years' time. And Horizon 3 is all about game-changing ideas, blue sky or wicked ideas. So the business units that we have in Mineral Resources, we work in Horizon 1 space, basically solving the challenges of our industry that the industry faces today. And I would like to show you a few examples of the research and science that we do. I selected a few in exploration and then mineral processing ends of the value chain, and I tried to select the WA-based examples. However, we work across Australia in all the states and territories. So we host a significant geophysics capability. It's quite large in our group, and we apply geophysics and petrophysics at various scales, from regional to district to deposit scale. Using geophysics to define lithological boundaries, improving the inversion models, and so forth. You probably know that we also conduct a lot of hydrogeochemistry research. Late Dave Gray was the pioneer in that space, and we collected vast amounts of hydrogeochemistry data across Australia. And now we shepherd our national waters geochemistry data set and making the data available via a platform that is called Exploration Toolkit, or XT. In this case, it's XT Hydro. which allows you not to only access the database, but also play with the data and, using this user-friendly platform. We also conduct extensive regolith and interfaces research, which helps us with understanding the nature of geochemical and mineralogical dispersion in different parts of the regolith, and tracking mineralogy and elemental distribution with depth to determine what type of deposit might be nearby. We developed the ultrafine plus technique that was commercialized to LabWest, an Australian SME service provider. And now, using the ultrafine technique, we are tracking Australia's critical minerals potential with a number of prospective areas already identified. We use data collected in detailed deposit scale studies on traditional and high-end analytical equipment and pivot that to on-site rapid laser-induced breakdown spectroscopy, or LIBS, analysis for precise mineralogy by training a machine learning algorithm. And we have also taken what we know to be anomalous signatures, geochemical, mineralogical, and textural, and combined these to build a new tool to determine the prospectivity of mafic, ultramafic bodies for nickel sulfide deposits, a tool called IM for nickel, or indicator minerals for nickel. And Louise Schonevel, the leader of this project, is in the audience, so you can ask her the technical questions you might have. Now I will take you to another example on the mineral processing end of the value chain. Demand for nickel in batteries is expected to increase fivefold in the next decade. And since 2016, our nickel sulfate process team has worked closely with BHP Nickel West. Together, they have conceived, developed, and piloted the process to deliver battery-grade nickel sulfate. This is a key precursor for cathodes used in modern lithium battery technology. The technology has been proven up by Nickel West and our team. It was commercialized with Nickel West investing in a new purpose-built facility right here in Kwinana. The nickel sulfide plant is the first of its kind in Australia. It has the potential to create a new Australian industry. The plant has created 80 new direct and 400 indirect jobs, and it will produce enough premium nickel sulfate to make batteries for 700,000 electric vehicles each year. So our efforts contributed toward enhancing Nickel West's position as a supplier of choice for the growing global electric battery market. It has helped to open the door for Australia in the shift towards electrification and reducing Australia's reliance on external supply chains. This has provided valuable sovereign capability for decarbonizing Australian future energy requirements. Now, last year, another exciting initiative was established by the Australian government, the Australian Critical Minerals R&D Hub. It's a partnership between ANSTO, CSIRO, Geoscience Australia, and the Australian government, and it is hosted by CSIRO. The majority of its funding is supporting new research which will help scale up and commercialize Australia's critical minerals sector and foster cooperation across domestic and international research ecosystems. And next week, the representatives of the hub and the stakeholders will be here in Perth at the Critical Minerals Conference. So in addition to all the R&D effort within the business units, we have two other exciting initiatives focusing on Horizon 2 and 3 R&D and their missions and future science platforms. CSIRO missions are bringing the ecosystem together to accelerate the pace and scale at which we solve national challenges, leveraging science and technology for impact. In Australian mineral domain, we have launched Towards Net Zero mission, which has the goal of focusing on innovation and capability building to help Australia's hardest to abate sectors, including steel and agriculture. This mission is supporting Australia's regions and mining industry by identifying what is required to develop new low-emission steel and iron ore production processes. And finally, Horizon 3 stuff. With our future science platforms, we're working on Horizon 3, really game-changing, boundary-pushing science that will underpin innovation and has the potential to reinvent and create new industries for Australia. We currently have a portfolio of about 16 future science platforms, and here I listed 5 that are working on some of the aspects and of some of the problems to help us transition to net zero. So that was a very quick snapshot of CSIRO's R&D powerhouse, which provided you with a showcase how at CSIRO we partner with industry, government, and the research sector to deliver breakthrough innovation across the resources value chain. Addressing the industry's greatest challenges, our research aims to benefit Australia and the globe by growing our resource base, particularly in critical minerals, responsibly and sustainably, and with increasing ESG performance and deeper Indigenous community engagement. Thank you very much.
Thank you, Yulia.